Alright, 9.3 video notes. I'm jumping into the sample problems, the example problems on the notes, and not doing the properties because we spent time in class, and I'm giving you a little chart that kind of summarizes all those properties. So I want to really get into actually solving some problems. So we're going to use the properties and apply them to get some numbers and get some answers here. So let's go ahead and let's jump into number one. I'm going to blow up this little parallelogram a little bit larger. Maybe stretch him out a little bit so he looks a little bit better. Alright, so it says find the numbered angles for the rhombus. So because it's a rhombus, some things I need to know. It's got all of the parallelogram properties. Alright, so there were 5 of those properties. But then for itself, it's got 4 equal sides. There were some things about the diagonals. The diagonals bisect each other like the parallelogram, but they're perpendicular. So that's kind of a key feature. So that right there is the big one that's going to help me out with this problem, is that I need to understand that all of these angles in here are 90 degrees. So angle number 1 is 90 degrees, the measure of that angle. Once I have that, I then can use the triangle sum theorem, and I know that, if this is 90 and this is 61, this guy's got to add up to 180. So I'm going to do 90, take away 61, and that'll give me this angle's 29. And then now there's another fact about rhombuses, that not only do the diags bisect and they're perpendicular, but the opposite angles get bisected as well. So opposite angles get bisected. And another way to think of it is these triangles all kind of reflect on top of each other. So basically, if this angle down here is 29, angle 4 is 29. And if I flip this triangle, over here would be 29, and over here would be 29. Because it's a parallelogram, I got to have opposite angles equal to each other. And then going the other way, these two are both 61. That makes sure that these 3 add up to 180. And then I have 61 and I have 61. So that fact is always going to kind of happen, that in a rhombus, the 4 triangles are all going to be congruent. So I kind of always keep that in my mind, that the 4 triangles have to be congruent in a rhombus. Alright, moving into number 2. You're building a frame for a window. The window will be installed and the opening shown. So they give me a drawing over here with it's framed in with wood. And it says the opening must be a rectangle. Given the measurements of the diagram, can you assume that it is? Well, the only thing I can see in the diagram is that this side is the same length as this side. And I also see that this side matches this side. So the answer is no. Okay? The only thing I know right now is it must be a parallelogram. Parallelogram. Because it's got opposite sides equal. But to be a rectangle, I need to know a little bit more. To be a rectangle, I have to be 90 degrees. So I got to have 4 right angles, and also I need to have diagonals that are congruent. So for part B, it says measure the diagonals. One of them is 58.4. So let's say this guy is 58.4, and then the other one is 55.3. All right, 55.3. So now what can I conclude about the shape? Well, it is definitely not a rectangle. Okay, a rectangle must have not only 4 right angles, but it also must have equal or congruent diagonals. Okay, so this is not a rectangle, it is a parallelogram. And this is a way that kind of old school carpenters use to when they pour a slab for a porch, or they build a deck, or anytime they want to make sure something is square, the rectangle has to have congruent diagonals. If not, then you have a parallelogram. Alright, moving right along. Number 3, in a rectangle QRST, QS is 5x minus 3. So QS right here is 5x minus 3, that's that one, and RT, which is the red one, is 2x plus 11. So if in fact it is a rectangle, to find the length, I know they must be equal. So QS has to equal RT if it is a rectangle. So 5x minus 3 is 2x plus 11. I now solve this. I subtract the 2x from both sides. And then I add the 3 to both sides. And I divide these out. And I get x is 14 over 3, 14 thirds. Man, I can't believe I put a decimal on here. Let me check my math and make sure I did this right. I minus the 2x. I add the 3 over. Yeah, 14 thirds. So now I have to find the length. I have to finish the problem and actually find the length of the diagonals. So I need to plug in 14 over 3 into either one. So let's do QS. QS was 5x minus 3, and I'm going to plug that in for x. So 5 times 14 thirds, well, the 5 times 14, that's 70 thirds minus 3. And 70 thirds is about, oh, what's that going there? Goes in there 2, that would be 60, 23 and 1/3. Take away 3. So it looks like 20 and 1/3, or 20.3 repeating if you want to use decimals. Either way, you can, I don't care if you use decimals or if you do fractions, either way, I'll take either answer on that one. All right, number 4, classify the quadrilateral. So classify means I got to name it. I got to say what I think it is. Now, just looking at this thing, I'm going to rule out rectangle and square because I don't see any 90-degree angles. To me, what I think this is either a parallelogram or a rhombus. Okay, it's a parallelogram or a rhombus. And I believe it is because I think that the sides are parallel. So I'm going to first check if these sides are parallel, and it looks like they are because it goes up 1 over 4, up 1 over 4. So I know the slopes, those slopes are a quarter. When I look at these slopes right here, those go up 4 over 1, up 4 over 1. So I know those are parallel. So I definitely know that I have both opposite. So both opposite sides have to be parallel because they were the same slope. Now the only difference, or one of the differences is between these two, how do they differ? Well, this dude's got 4 equal sides. So I have to find out how long each side is, and I have to measure it. Well, my slope actually helped me out. You know, both of these lines had a slope of 4 and 1, up 4 over 1 or up 1 over 4. So if I want to find the length of this side, I basically can create a little right triangle. You know, the length of that side is right here. This represents the red line, and if I use Pythagorean Theorem, it's a 1 by 4 triangle. So 1 squared plus 4 squared equals c squared, or take the square root of it, and that comes out to be the square root of 17. And I believe if you do that for all of these, every single one of these lines is the square root of 17. So this is definitely a rhombus. And how do I know it's a rhombus? Because it has 4 equal sides. They're equal length. I measured it using the Pythagorean Theorem. You could also use the distance formula. I don't really like the distance formula, but you could use it as well. Now I do see one little thing that I think I may have made a little bit of a blunder. Looking at the grid, it looks like every square goes by 2. Because I noticed this point right here is at 4, 0, and this point is at 6, 8. So everyone went by 2. So actually, you know, what I did here was kind of wrong. Okay, what was kind of wrong, and I'm going to just modify it a little bit. Because instead of being 1 and 4, it's actually 2 and 8. it would be over 2 more up 8. So that would be the square root of 2 squared plus 8 squared, which is the square root of 68. So that's how long each side is. Not 17s here, but the square root of 68. But nevertheless, it's still a rhombus because it has 4 equal sides. All right, this guy over here, well, I am pretty confident that not all 4 sides we don't have 2 sets of parallel sides. So that wipes out all the parallelograms, rhombuses, rectangles, squares. But to me, this looks like a trapezoid. So I'm going to just double check to see if it's a trapezoid. And all I need to make sure is that it has 1 pair of parallel sides. Well, the slope of this line is 1/2, up 1 over 2. The slope of this line is up 2 over 4, which is also 1/2. So yes, this is a trapezoid for sure, because I have 1 pair of parallel sides. I check their slopes, they're equal. Now I can just visually see, this side has an undefined slope, this side has a negative slope, so I know it's not a parallelogram. They have different slopes. Now the only other question is it isosceles? Is it an isosceles trapezoid? So now I have to ask myself this question. It might be more than just a trapezoid. Kind of looks like it is. However, to be an isosceles trapezoid, I have to check to see if it has equal sides or equal legs. And I can do that, using the Pythagorean theorem. This little one here, well, that slant, if I actually make a right triangle out of it, I kind of make a little right triangle here, it's 2 by 2. So that would be 2 squared plus 2 squared. So that would be the square root of 8. So side ST is the square root of 8. Now, this other side that I thought might be equal, when I look over here at that side, that one's pretty easy because it's just 3 blocks high. So R to O is actually 3. So these are not congruent. They're not equal. So I can say, wait a minute, definitely not isosceles. It's just a regular old trapezoid. So sometimes you have to go through a few different pieces of evidence before you can exactly know who it is. All right, last few problems are dealing here with mid-segment. So remember that in the notes, the mid-segment is the average of the bases. So basically I'm going to add the 2 bases up and I'm going to chop it in half. So I take 12 and 28. I got to see what's exactly in the middle. So I average them. And that comes out to be 40 divided by 2. So 20. It should be the exact average or middle number between the two. Doing it on the grid here, I have to find YZ. So basically what I have to do is I have to average T to U and S to V. So I got to add TU plus SV and then chop it in half. So doing Pythagorean theorem, this leg right here is 2 squared by 4 squared. Take the square root of that, which is the square root of 20. And then I need to find this little fella over here, which he's a 1 by 2. So he is 1 squared plus 2 squared, which is the square root of 5. So I'm gonna average those two out. So let's go ahead and let's get decimals for this. If you wanted to keep it exact, I could say, oh, it's a square root of 20 plus a square root of 5 chopped in half. That would be the true, the exact answer. But let's just get some decimals here. Let's do the square root of 20, which is about 4.47, and then the square root of 5, which is about 2.24. Add those together, divide by 2. So let's just do that. 4.47 plus 2.24 equals, divided by 2, get about 3.355, 3.36 maybe, somewhere in that area, 3.3, 3.4. I don't really care. If you can get down to there, you're doing very well. Key idea is you average the two and you have to find the distance. Now, same problem using algebra. If I use algebra, I have to add this guy and this guy together to average them out and get 12.5. So you could set that up with algebra. I'm not going to do that way, but you could. You could go 3x plus 1. That's base number 1. And then add that to base number 2. Maybe I will do it this way. Add that to base 2. Chop all that in half. And the answer is the median. Now this isn't too bad to solve, because when I want to solve this problem, I can start off by multiplying 2 by both sides. So 2 times 12.5 is 25. Clean this up a little bit. I'm going to combine some like terms. So all I did was add the 1 and the 15. Subtract 16 from both sides. And divide both sides by 3. And it looks like x equals 9. And let's just plug that in and see if it works. Or x equals 3, I should say. 3 times 3 is 9, plus 1, that would make him 10. So let's check these numbers. 10 on the top, 15 on the bottom. Who's exactly halfway between those two numbers? It is 12.5. Now, some people solve this a little bit differently. I will show you on the warm-up how to do that maybe a little bit faster, but I kind of showed you the traditional route first. All right, this last one, find the measure of angle G. Well, looking at the shape, based on its markings, this shape is a kite, because I have some equal sides here, and then I have a pair of equal sides here. So some things you need to know about a kite. The kite is basically, it's a triangle folded over on top of itself. So I know that this angle is going to equal that angle. All right. So kind of going back to our properties from in the very first chapter, all quadrilaterals add up to 360. But I already have 140. So when I do 360 minus the 140 I have, that leaves me with 220 degrees left. But I got to split it up between angle E and angle G. So you got to divide that by 2. So it looks like 110 degrees would be for E, and 110 would be for G. That way they all add up to 360. All right, so a lot of questions can be asked. We have a lot of shapes we're looking at. These are just the properties. More importantly, we're going to get into the area and perimeter, but these are some of the questions that you could be asked involving the quadrilaterals. So hopefully this will get you ready for the practice tomorrow. See you.